Hello, welcome guys. Today I will discuss a very famous and very useful algorithm in artificial intelligence for distance measurement, because most of the time to deal with your graph, to deal with your uh, transmitting information from one neuron to another neuron using any path or distances, we need some algorithms. So here we can use it as we can use heap or tree structure, and to traverse that we need some algorithm. So this algorithm is based on shortest path algorithm. Shortest path means the one node who has the least distance would be considered and would be followed, but there are certain rules. For example, the first rule is our node value. If node value is less than infinity, then we can replace that value with the new value. If it is greater than the existing value, then we can ignore. Okay. And originally every node except initial node has weight value as infinity, and other has an initial, the starting point or an initial node has zero value. So here let's take an example of using DIJKSTRA'S algorithm. It's also known as the shortest path algorithm. This algorithm is very famous in heap structure and also in data structures. So when you are dealing with any distance measurement, you will need this algorithm, because this algorithm has a better efficiency and better accuracy. So let's take an example. If our starting point is A and A has three connected nodes, like A with B, A with C, is connected with this, A, B, C, D, and here E. And I am just taking a random example. You can draw any graph, and you can actually use this algorithm and implement it on any graph. So here you see, okay, this is our starting point. So for starting point, the value of the starting point, the weight of the starting point is 0, and other has infinity. So you see the basic rule that our node value has if less than infinity, so we can replace that node value with our new value, with our current value. Else we'll left it as it is. We'll ignore. If it is greater, then we'll ignore. So and every node has infinity value, and our starting position has 0 value, because you see the distance between A to A is 0. If you are in London and you want to go on to London, to any specific destination, then you are at your own position. You will not even move to any place. So your starting distance is always 0, and this is the rule for this algorithm, that the remaining points has infinity values. So here another factor which is very important is the distance between 2 points. Let's suppose we have 3, 4, 3. This I am selecting it randomly because my purpose is to just first make you understand that how to deal with this. Let's suppose 3, 2, 5, 7. Okay, let's start. So using this algorithm, if we see A as starting position and this is our destination, this is our source. So to move from source to destination, if you are at A position, A has 0 value. With 0 value, you will have 3 paths with E, C and B. And now this algorithm run it as, to go from A to B we have 4 value, to go from A to C we have 3, to go from A to E we have 7 value. So here we'll see our rule is smallest distance will get preference. Like while you are making your array, visited array or final route, while you are making your final route or route, first node is our A point, and to go to next node we'll consider which node has smallest value. So you'll see from to compare 3, 4, 7, which is the smallest is 3. So from A we'll go to C, we will go to C, and our you see from A to C we have 3 value, and 3 is less than infinity. So our node value is less than infinity, so you need to replace with 3, right? And it's the same to go to A to B, we will need value 4, and to go to A to E we will need 7. So see, our weights are updated, our nodes value are updated based on specific condition that we are following is following in this particular algorithm, that our node value, if it is less than infinity, you'll need to replace. And let's go ahead forward. So we are at C position. C, we can go to B, we can go to D, and we can go to E. See, we have 3 conditions. To go to B we have 6 value, 6 distance. To go to D we have 11. To go to E we have 8. So 6 is the smallest one. So we'll go from C to B, and our you'll see that our weight now is 3 plus 6. 3 plus 6, 9. Now our new weight is 9, and you see that our previous weight was 4, and 4 is less than 9. So if it is less than the new weight, then you need to ignore it. Okay, if it was 1 as compared to 4, then we replace 1 and we use 4 forwardly and accordingly. in our next move. So we are at B position, we are at C. From C we are at B position, and our visited node is B. So at B we have 4. So to go to B, we have C, we have A, C and D. Now you see we have another rule, that visited node already visited node, जो like the node you have already visited will be ignored. Okay, so we will ignore this node and we'll move forward, like from B to A is already visited, from B to C is already visited, from B to D is new node, so you can go to D. Now your weight on B was 4 and weight on D was, the distance was 5, sorry, excuse me. So you need to add these weights, 4 plus 5, 9, and you see that 9 is less than infinity, so you need to replace it with 9 with your new weight. So our new visited node is D. Now to go to destination, we have two. D will go to F, D will go to G, D will go to E. Now if you consider it like all nodes haven't visited yet, so first you need to go to the specific E node, because E and F has equal weight, so you need to go to any of them. But you see that our target value is our target point and destination was F, so we need some shortest path to go to F, and also the path which is more and more easy and quick, like this, if you go to E, you will get to G and then F, and it will not be very quick, very fast. So when you go to like D to E, first you consider D to F, and your 9 plus 2 means 11. You get 11 and you need to replace it with infinity, because your current value is less than infinity, so you need to replace. So you see that our path, so our, like, to go to E you need another big route, and you see that if you go to E you will get 7 plus 2 9, 7 plus 2 9, and then you will need to go to G, 7 plus 2 9 with 9, and 9 plus 5 14, and then 14 plus 3 17. So you see, if you go from this path, it's just a senseless, it's just useless. So while you can get the least value, least cost with shortest distance, you will just stop. Okay, and let's suppose someone do it, then you need to compare that which path has smallest value, and you need to stop it here. So our visited and final route was A to C and B to D and F, and our cost is 11. So you see, cost is just like a fare. You need to go from one path to another path, to from one source to another destination, and for this you need better fare and with quick time. So first you will go A to C, and then C to B, and then B to D, and D to F. So this route will be smallest and accurate path. So this is all about this algorithm, Dijkstra's algorithm, and this algorithm is very famous algorithm in our artificial intelligence distance measurement. And sometime when you maximize the efficiency and profit, then these type of situation, this algorithm really worth. So first you need to make it as pseudocode, and then you need to code it, because first you need to understand, and then you can see that to transmit any information, to go through any problem, what type of algorithm will be more suitable for you. That's all about this video. If you have any question, you can comment on comment section. And thanks for watching. Bye.